Next up is explaining Newton's second law of motion. Newton's second law of motion, there's not a lot of explanation behind it, but it's a very kind of mathematical one that is actually in reality going to be where we spend most of our time in the course, actually calculating what the motion of an object looks like using Newton's second law of motion. So let me introduce it first. Let me kind of say it in words first before I give you the equation, because it's important to really wrap your head around what it means. Newton's second law of motion says that the total sum of all force vectors that are acting on an object are in the same direction as the object's acceleration. Okay, so I sort of packed a lot of information into that sentence. Let me unpack it a little bit. So first of all, let me make special note that this law applies to the total sum of all force vectors only. So as a result, this is why we just spent some time learning how to sum vectors. You might have wondered a little bit why we spent so much time on that. It's because it turns out, in reality, what matters in terms of determining the motion of an object is the sum of all the forces acting on it. Now, forces, by the way, I haven't really defined that term, but forces are basically like pushes and pulls. You can see intuitively that that has a direction associated with it. You know, I can pull something in this direction, or I can pull it in this direction, or I can pull it in this direction, and that will have a different effect on the object's motion. So an object might be under the influence of many different forces, which we'll learn about in great detail later. Once you know all those forces that are acting on the object, you add them all up, add as vectors using the vector addition method. And once you've done that, it tells you the object's acceleration. So second observation here, what this law tells us is about the object's acceleration. So review what acceleration means. Because acceleration is definitely not the most intuitive property of an object's motion, but it turns out to be a really important one just because of how physics shakes out. It turns out that the acceleration is what you are actually going to be calculating about the object's motion most of the time. So just like you can go back and review what acceleration is on your own, but just to give you like the super quick version, acceleration vector points in the direction that the object's velocity is changing. And remember that acceleration in the same direction as velocity causes a speed increase. Opposite direction from velocity causes a speed decrease. And if it's perpendicular to the velocity, that causes turning. And remember what we said in the Newton's first law video, that you need a force to create anything other than straight line motion at constant speed. So that's ties hand in hand with this idea, because acceleration can cause a change in speed or it can cause a change in direction. All right, now, what's the actual equation? Well, the simplest way to state it, and the way people normally write it, the way I like to write it, is F vector equals, that's the force, equals M, that's the object's mass, times A, that's the acceleration. So one thing I want to really draw attention to here, because this is the most common mistake that people make. I already said it a couple times on the slide, but I'm going to say it again. Remember that F represents the total sum of all forces acting on the object, not just one force. So you have to first add up all the forces. Some people like to use like summation symbol F equals ma to represent this equation. I never really found that very helpful as a student because, you know, what does the summation symbol really mean? But the concept of what it means is that you have to sum all the forces first. Okay, and A, of course, is the object's acceleration vector. Another thing to make note of here, F is the forces that are acting on the object, not the forces that that object is exerting on other objects or whatever. It's the forces acting on the object. And A is that same object's acceleration. M is that same object's mass. So make sure, this is another thing that people sometimes get wrong when you start to get more complicated problems where there's like multiple objects involved. Make sure that M refers to the object of the mass you currently have your eye on. A is the acceleration of the mass you currently have your eye on. And F is the forces on the object you currently have your eye on. Okay, so that is the big equation that the next long time is going to be based around solving that equation. So let me maybe stop this video here and do a separate video to walk you through the steps of how you actually go about solving that equation.